What is this? Yeah. So this is test 2, right? Test 2, number theory. So I don't know if you guys remember, but if you do, then how did you find the test? Please share your experience. Anything, just say. Okay. Okay, so how much time did you spend? I mean, Ishana, was it 60 minutes? Yeah, whatever. Did you spend the whole, were you able to spend the whole time thinking about it? Did it occupy all of your time? Or, sorry, say it louder. 60 minutes. Was it a 60 minutes paper? Okay, good. I cannot hear you. Maybe it's a different place. Anyways, yeah, yes. That's the whole point, is that it should occupy all your time. There should be a struggle. You may not be able to do the paper, but it should occupy all of your time. At least that's this, I think, in that simple way to begin with. So, all right. So let us begin with question number 1. Find all integers x plus y plus z so that this happens. Okay. Yeah. Find. So what I want to do is I want to find all integer solutions. Okay? Find all integer solutions. Yeah. So what most of you, both of you have done is you have given me infinitely many solutions, but I don't think any one of you gave me all the solutions. So Aparna, would you like to tell me how you have done it? If you, because I told you to try more after that. I mean, let's see. Right. 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 Yes, certainly you have infinitely many solutions. Yeah. Infinitely many solutions, infinite solutions. But then how do you know that the solutions which I understand the process, I get the process. I mean, my point is that how do you know that those infinitely many solutions are all the solutions? You see, so what I'm just saying is that, I mean, even if you just give me this, okay, and I don't know, I could say that, okay, I mean, in this case, it is fine. It's a small thing, but let us take something. So let us say that this equal to 3. Okay. So I want to produce an example where I will give you infinitely many solutions, but they won't be all the solutions. Do anyone want to try that? Give you infinitely many solutions, but not all the solutions. So let me, because I'm asking this question, could be a little vague. What I'm saying is that 1 plus 2 is 3, right? So what I can then just say, okay, take this for any t, any integer t. Have I given you infinitely many solutions? Yes. Have I given you all the solutions? Mhm. Will this give me all the solutions? T, where t is an integer. Just think, is there any solution missing? Right, 0 and 3. Absolutely perfect. Yeah, Ishana, do you see that? Yes, I mean 1 plus 2t will be always odd, but you mean x can be an even number also. Missing, certainly missing. I'm skipping I'm going to 2t. This is the point. And this is, I mean, so this is the thing. I mean, the main transition that one of the things that one has to get comfortable more and more is the infinity concept. What is infinity? What size? This is what we are getting comfortable. Okay. So now the question is, how do we say that what we produce here is all the solutions? Find all. So we'll keep it very simple. Right? You basically fix a z, because that's what you guys have done, sort of, right? You fix the z and you find x and y. I don't remember, to be honest, because it was some time back, but fix the z and you find all possible x and y, right? Fix z. Because see, if I fix a z and I find all possible x and y, right? I go to a different z and I find all possible x and y, and a different z and all possible x and y. Am I going to miss any x and y? Am I going to miss any x, y, z? Any solution? Yeah. I wouldn't miss any solution, right? That's the thing. That's may not be a good way, but that's at least a fail proof. Fail. Okay, so fix z. So the meeting will end in 5 minutes because there was some strange limitations, more and more limitations. Earlier it was some 60 minutes and 45 minutes. Now there's a 40-minute limit. So fix z and now find all solutions. Find all x and y. So find all x and y which satisfy this. Now I'm not writing z equal to 2, but I want you guys to be able to assume that z is fixed and work in that way. And tell me solutions of x and y. So imagine z is just fixed. 1 minus z is just a number. Just some r. Just fixed r. For that, you can use the formula. You have a formula for that. So that is based on the same principle, right? You find one solution and then you find all of them by the shifts. Same thing. Right? I mean, like not, yeah, just find or guess, whatever. Find one solution. Generate all, but just saying find all. That's it. What is one solution? Am I rushing it? Is it clear? Find one solution and then shift them to find all solutions. Yes, exactly. That you can find one solution and you can shift it. So we had proved this, right? That you can look at this ax plus by equal to d, 2x plus 3y equal to 1 or 5, that does not matter. As long as it's a multiple of the GCD, I mean, even if it's 2 and 4, okay, and this is 12, still solution exists. Yes, now find one solution and the shift to find all solutions. Ishana, is that okay? That 12 doesn't have to be the GCD exactly. That was the key. That 12 does not have to be the GCD. It can be a multiple of the GCD, and this method, you will get all the solutions still. That was I think that was an important thing. Yeah. I mean, and if you forget, like I always forget, And you prove it. You prove it, right? That if I find one solution, ax naught plus by naught equal to d, other solution would look like a shift by difference, taking the difference and so on. So you just prove it. If you're ever in doubt, prove it. That's why it's maths. You don't have to believe. Yeah. So what is one solution? So that's the you have to it's just a fixed number. It is just some r, which is a fixed number, but its value is not known. That is the one step. That is a step extra thing in this question, which you have to get comfortable and do. In the sense that usually we put r equal to some number, but well, r is just a number. It is just a number, right? So you can take, you can just take x equal to 1 and y equal to r minus 1, right? This is a solution, right? Or if you don't want, you can just take x equal to 1. Then it just becomes minus z, y equal to minus z. Is that okay? Okay, that's all it is. If I'm tell me, okay. So this is one solution, and now what are all the solutions? Just the shifts, and here the shifts are just t and minus t and z, and this will work for any z. Okay, I just write this. So is it now making sense that we have gotten all the solutions? All right. Okay, I'll just launch the meeting once again. It will just close. Okay.